Hi everybody, how's it going? Brian here. So today I am going to talk about why you would mate something like GraphQL and gRPC and why that's actually a really good idea. So GraphQL is awesome because it's a flexible API, right? So instead of having to have, this call, that call, that call, that call, just in case you get different fields or, APIs just always have the tendency to like over deliver. And so instead of having to create like this, that, and the other in terms of API endpoints, which can get really complex and annoying, you can use GraphQL. And GraphQL allows you to be very flexible about what schema you use to call that API. And so you can have like, different endpoints for like a version. That makes it very easy to have like backwards compatibility with certain services. The issue with GraphQL is that you're essentially abstracting the entire functionality of your backend to the backend of that API. So the API itself actually has a server and a client structure to it. The GraphQL operates as the server, and then the gRPC has multiple clients on the back end. So let's say that you have multiple services that you want to be able to call from dynamically. You don't necessarily, if you're not asking for information from server A, why call server A at all? GraphQL allows you to do that. So you'll have a GraphQL server and gRPC clients. And you mate those two together, and it makes for a really interesting API layer that you can build. And so that's what I'm going to build today. It's fairly simple. I'm going to assume that basically you're at the end of like the 99 Designs quick intro, but then we'll start it up after that. Cool. So the first thing that I'm going to do is I'm going to replace the default handler that comes with GraphQL, just because I prefer Gin. It's probably the most popular HTTP handler out there, and it's just better. And it gives you pretty colors by default in the logging. So I'm going to do that right now. Okay, so what do we have here? We've basically just recreated the two endpoints that automatically come sort of like out of the box with this. I'm not going to go super into Gin. This isn't a Gin video; it's a GraphQL video. But suffice to say that this is just handling the GraphQL playground, and it's also handling when we make a query, because that's what we're going to be doing. We're going to be making queries. So the next thing that we're going to do is we're going to go to our GQL, our graph file, and here you're going to see two directories, generated and model, in addition to three files, resolver.go, schema.graphqls, and schema.resolvers.go. Generated and model are both generated. Do not touch them. Do not edit them. You should never be within these directories unless you super know what you're doing, in which case, why are you watching an intro to GraphQL video? Here we have our resolver, which is in our resolver.go file. This is kind of where you put like local and memory dependencies. Basically think like pointers that you instantiate at some point in the program. Here is our actual schema. As you can see, this is literally the schema that's given in like the basics when we generate things. And then here is our schema resolvers. So I'm going to significantly simplify this just for the sake of argument of like just getting started. So let's do that now. So this is just a very simple schema that I'm using, that basically saying, hey, I am getting some kind of request a query for return time, and that's going to return a return time object. So the idea of this is basically like I'm going to call possibly 3 different gRPC services, each one of them on a different port. And I want them to return, let's say, like the Unix time. Like I just want them to generate it, and then I want them to return it. That's kind of where I'm thinking like we should sort of go with this. One thing that I do want you to note is that I do have a make file up here. I put these in all of my projects because it makes your life a lot easier. So we have make GraphQL, which means we generate the GraphQL. We have a make proto, which is all of our proto stuff, which we'll get into. We have a dep, which is a mod tidy, a mod vendor, and a format. And then we have build and run and clean. Although build and clean we're not going to super get into, but like use this. It's really good. So you notice whenever we create run our GraphQL, like if we remove objects, we're going to have errors. And that's just because it takes all this code down here, or that was here, and then it puts it down here for you to delete. I'm not going to delete it. Let's just edit it out. I don't really care. But what are you left with here? I mean, we're left with a very, very simple resolver. And here, our query resolver return. We take there's a pointer receiver to a resolver struct titled query within generated query returns the query resolver of R, whatever we basically hand it. This is the thing that you're really going to be in on is these basically some kind of like request resolver, right? This is where stuff is actually gonna like kind of the magic's gonna happen. Right now it's gonna panic if we ran this and tried to make a request because the only thing that we've implemented is a panic. So we need to change that. So what is a return time object? Let's just try setting up the GraphQL API and see how it goes, and I'll just make a dummy object for us to give us a shot. Let's see what it says. Cool. Here you can see server 1, server 2. Let's add server 1 here. Just run our query. Hey, what do you know? It works. Let's try it without server 2. Cool. So now we can see that this does actually work. So now that we can see that GraphQL works, we can actually start working on our gRPC stuff. So let's make a folder, call it gRPC stuff. Cool. Okay. So now we're gonna go into gRPC stuff. You see there's nothing in here, but we are going to make a proto file, and we're just going to call it schema.proto. Cool. So we close graph, gRPC stuff. As you can see, there's nothing here. This is just sort of a modified cut and pasted one from the just the Hello World greeter client and server example from gRPC Go's lib. So we are going to call it this. And let's do a commit because this is a good spot to. Cool. Notice how I do like a make dep almost after everything. It just clears up so many things. So just like if you're ever running into issues where like something isn't generated properly or whatever, just do make dep, and stuff will probably work out for you. So let's look at our schema.proto here. So what's our schema pro? I mean, we're literally making a hello request and we're getting a hello reply, and that's just a message of string, right? And it's just a very, very simple RPC call. Really nothing sort of crazy there. But we need to make this server and everything available in like kind of a nice, convenient little package, right? So we're going to make a new file and we're going to call it utility. I mean, it works okay, you know. So we can do package RPC stuff. Right. And we're going to want to just make like a standard, like I want to dial the RPC, right? I want to get a new client to that RPC, and then I want to create like a timeout, and then I want to say something. I want to say to the RPC connection, hey, I'm a client, I have a message for you, in which case I'll get something back, right? So let's make basically like a client connection function. So what do we do here, right? We dialed it. We're not using any transport credentials because we're just doing insecure because it's just local development, so no TLS, although there's no reason why you couldn't implement TLS on here just like you would with Gin, just like you would with like any other, you know, layer of communication. You just add some middleware in there. Not really a big deal. We defer closing the connection. Always remember with defers, they execute in the opposite order in which you declare them. That's a very important sort of gotcha. We create a new gritter client from that connection, and we give it a timeout with using the background context, and we just say, hey, if it's background context plus 1 second, things have gone awry and cancel, and we need to error. From there, we just say, hey, say hello, give it the name of server, and then get the response. Now, actually, what I'm going to say here is I want to do something a little more interesting. I'm going to give it a name. And let's see what happens. Right? If there's an error, we couldn't greet or whatever, and the thing that we want to return here is whatever the message response is. So now we're back at our our resolver. So now here, instead of saying hi, right, I want to get a response from my RPC server that gives me a name, right, or gives me back. It's just going to basically just give me back a string, right? Who cares? So we're going to say RPC stuff.get client con, right? Remember, we're giving it a name and an address and then name, excuse me. So So now we need to instantiate a say hello server, which we can do simply from the RPC example library. So here is just the example server that's off of the gRPC Go examples. I did modify this so it'll say, hey, I'm on server 1 right now, and it will return. So let's get this guy going. Cool. It says it's listening. And I got this set up, so now it's running, and it's supposed to dial on this connection. So here we can see I'm going to ask for server 1 and server 3. Give me back something, right? Hey, what do you know? Look at that. We got a 200. Only took, let's see here. How long does it take? It takes in the milliseconds, which is fine. 1.2, 1.4 milliseconds is really, really good performance. And think about that. Like, we're communicating with an entirely different thing. So obviously it's going to go from something like microseconds because we're just generating junk, because now we're actually connecting to something else. So this is really, really cool. So here's the thing, though, and here's what I want you to realize. Let's say that we don't necessarily want to call every single service every single time. We actually want to have a resolver custom so that when for each, say, specific service that we're calling, we would instantiate an RPC call for that, right? Because if I were to come in here, for example, and say I wanted to take this, put it here, and call this server 2, right? Like, you'll notice in here, I'm not even calling server 2. The call still succeeds, but you'll see that when I make this call, so let's run this again, and then go here. You'll see if I call server 3, we're going to get an error code here. And it's going to say, hey, there's nothing at 50052. Like, what are you doing? But notice that we're not even calling server 2, right? So what does that mean? There's going to be certain times where, like, even if you, in this structure, even if you're not calling like server 2 here, you don't have a custom resolver per field. And so it's just going to send out everything every single time. So the lesson here is, let's actually create custom fields. So the way that you're going to create custom fields is you have to go into your GraphQL YAML, and you're going to come down here, and we're going to start talking about different models. So for our let's just create like a custom resolver for server 1 and server 2, and you'll see some magic there to make that happen. Okay, so now you'll notice all of a sudden I have these 2 other resolvers here. I have return time resolver for server 1 and for server 2. Let's see some movie magic here. So watch. I'm going to return string 3, right? But I'm not going to call string 2 here. So you see, that still works totally fine. And then when we go back to our VS Code, you can see here, all of a sudden there's no error. And that's because we're not even calling that field. If we're not calling the field, which has its own custom resolver, then the resolver itself never gets called. And that is the magic right there. You can have as many services as you want to connect to on the back end. And if you have a custom resolver per field, you don't call the ones that you don't need. And that is magic. And so basically, in the end, this sort of the top level resolver sort of becomes like your base query resolver. And the rest of it becomes sort of like stuff that you only have to call when things are structured in a certain manner. So obviously, again, this is a very basic tutorial, but I think it gives you at least an idea of like how to be able to call different services, because there's no reason why one of these resolvers can't be a database connection. There's no reason it can't be like a connection to a Postgres database, can't be a connection to a Redis cache, can't be a connection to an RPC service, can't be a connection to a WebSocket. Like, all of these things can be connections, and you'll only call them when you need them if you create custom resolvers. That is part 1 of GraphQL and gRPC together. Thank you for your time.